Okay, welcome to the Thailand International Mathematical Olympic mock examination 2001 to 2002. This is for the student of primary 6. And this paper consists of 30 questions separated into 5 different topics: logical thinking, arithmetics, number theory, geometry, and finally, combinatorics. And you have 90 minutes to finish this paper. This just the same as the real examination. So just one thing to remind you is that you have only 3 minutes to finish each question. So time is of its essence. And if you have no idea how to solve the question at the first glance, it is better for you to just skip the question and go to the next question. Please do not just I know that some students would like to finish this question one by one, starting from question 1 or until to the last question. But it is not advisable for you to do that because time is of the essence. You have only 3 minutes to finish each question. So if you do not know how to solve a question in the first glance, maybe it's better for you to just skip the questions. Okay? So without further ado, let's go. Okay, so now the date of the real examination is actually announced in the web page of this competition. So you may want to look back into the homepage for further details. Okay, so let's go to the first question. Okay, find the average of the following number. Now, what is the meaning of average? Average means we add all this number together and then divide it by the number of terms. Is the total divided by the number of terms. So all we need to do is to find out the total. All we need to do is find out the total, because we know that in this case, because there are 8 numbers, so we already know that the number of terms is 8. So all we need to do is just sum them all. Now, by summing it all, you can try to sum it directly, but it is not advisable because these numbers are big. Instead, you should try to think of all this number as 2000 plus or minus some number. So for example, the first number is 2000 plus 20. For our second number, it will be 2000 plus 22. For our third number is 2000 minus 13. Now notice that 1987 is 2000 minus 13. And for our fourth number is 2000 plus 21. And then it will be plus 47 minus 8. Again, 2000 minus 8 is 1992. And then this will be plus 4. And then this would be plus 35. So instead of adding all this 2000 again and again and again and again and again, instead, we would like to add these simpler numbers. Okay, so what's the sum of this? Well, the sum of all these 8 numbers, plus 20, plus 21, and then minus 13, minus 8, and so on. Now you can easily see that you can cancel some of them. For example, so minus 13, minus 8, and can be canceled out with our minus 21. So all you need to do is just sum all the others. And by this, for example, if our 22 plus our 47 plus our 4, it would be equals to 69 plus 4, which is 73. 73 plus 45 is 108 plus 20, and hence it would be equals to plus 128. Plus 128. So you know that the sum consists of 2 parts. One is the base, which is our 2008 of the 2000. This is the base of it. equals 16000, and then you need to add 128 of it. So the total will be 16128. So if we try to divide them, our average will now becomes our 16128 divided by our 8. So it will be equals to 2016. 2016. And 2016 is our answer. Or this is 100 and 130. No, it's not 130. Why? Why? Yeah. 2 plus 7 plus 4 plus 5, 6 plus also 2 plus 7 plus this is equals to 12. Wait, what? Oh, yes, it is equals to 12. Yes. So, and then it will be equals to 16. Yes. And then add 2, it will be equals to 18. Right? Yes. Yes. Yes, definitely. So the sum will be 128. Right? Okay. So now again, well, please do. Now you need to take time to check your answer. Okay. So this is our question 1. Okay. So let's go to our second question. Our question number 2. There are 23 pieces of red chopstick, 9 pieces of green, and 11 pieces of orange. Mix it together. If you want to get 2 pairs of chopstick, red chopstick, and 1 pair of orange chopstick in the dark, at least how many? Now, here are the keywords. Whenever you see a question like this, it gave you a situation, and then it will ask you how many things you need to do at least. Okay, this is always asking you to use the principle of least favorable. Principle of least favorable. Now, this is always the case. Whenever you see a question which asks you at least something, this is always the principle of least favorable. Now, what is the principle of least favorable? Is to yes, this is the worst case scenario. Yeah, this is another way of saying this is the worst case scenario. Yeah, again, very, very good. Thank you. Worst case scenario. Now, how? Now, I don't have space to do this. So let me write it down. Is to consider. I still do not have space. Now maybe I just use a smaller text. Okay, you just use a small text. Okay, what do you mean by principle of least favorable? Is to consider the opposite. Consider the opposite of the things we want. And too big. Okay. Okay, so now what do you mean by that? Because in here we will have 2 conditions that we would like to talk about. We have 2 pairs of red chopsticks and 1 pair of orange chopsticks. Well, what is the reverse of what's the opposite of this? What's the opposite of this? The opposite of this is not 2 pairs of red chocolate and a pair of orange chocolate. Is no for red, right? No for red, because 2 pairs of red chopstick means 4 red chopstick, okay? Or now it doesn't need that both of them is true, or only one of them is true is okay. Or you do not have no 2 orange. Okay. This statement is the direct opposite of the statement in green. This is the direct opposite of the statement in green. The whole thing. Okay. Because we want 2 pairs of red chopstick, we want 4 or more red chopsticks and 2 orange chopsticks. Okay. So what's the reverse of it? Is either you do not have 4 red or you do not have 2 orange. So this is the direct opposite. But now, once you think about this, then you may find that it is much easier because we can separate them into 2 cases. One is the first one, no 4 red. The other is for our no 2 orange. Now let's consider now, excuse me, could you please stop drawing on the screen? Now let's talk about it in the first cases. For our first cases, because it is no 4 red, which means that all the red can have at most 3. But the red have 23, so we have at most 3. So you can get as many green as you want, and you can get as many orange as you want. So it means that it has at most 3 plus 9 plus 11, it will be equals to 23. Now again, excuse me, please do not draw on the screen unless I ask you so.
Okay.
This is the first condition.
By the way, okay.
Now, for our second condition, no 2 orange, it would be at most, because there are no 2 orange, so you can take as many red as possible, 23 red, or 9 green, and because there are no 2 orange, so you can take at most 1 orange, right? So it will combined together will be 33. So which means that if you want this to happen, if you want our orange condition to happen, you either can take at most 23 or you can take at most 33. So what's the largest of it? The largest of it
34.
is, of course,
It's 34.
Yes, it's 34.
Because it says 1 pair of orange chopsticks.
Wait, stop.
Okay, yes.
Yes.
Please. Let me finish it first, okay? Let me finish it first. Now, but in here, some of you have said that it is, yes, the 2 orange is for a pair of orange, yes, okay? Yes, it's for a pair of orange, but notice that in here, all we need to do is to talk about how it will satisfy these conditions. But this condition is the direct opposite of what we want, okay? So it would be at most 33. No, please do not. Now, please let me finish it first before you discuss. Although your answer is correct, but please let me finish first, okay? Now, notice that in here we consider the opposite thing. So it means that if the opposite is true, then it has at most 33. So what is the opposite of this statement? We now want to consider the opposite of this statement. The opposite of this statement must be at least 34. So that's why 34 is the answer. Now again, let me repeat it one more time. The principle of least favorable or the worst case scenario is to consider the opposite of the things that we want. Now, given the opposite of the thing, given the opposite of the things that we want, we conclude that if we want the orange case to be true, there can be at most 33 chopsticks. There can be at most 33 chopsticks. So in the worst case scenario, we can pick 33 chopsticks and we still do not get the green condition that we want, right? So it means that if we have more than 33, so it will be at least 34 chopsticks, then we will satisfy our green condition. This is the principle of the least favorable. This is the principle of least favorable. We consider the direct opposite of it. We find out the things that it can have at most, and the direct opposite of it will be the things that will satisfy our green, because our green and the orange is direct opposite to each other. Okay, so this is our second question. Now, because the principle of least favorable is a little bit abstract, so I have spent some time to discuss it. Okay, so let's go to our question number 3. It requires 20 minutes to cut a piece of wood into 6 sections. If the time required to cut each section is the same and you cannot stack your wood and cut them together, so what is the number of times that you need to cut a wood into 30 sections? Now, this is a tricky question. This is not hard as if it is question number 2, but it is tricky. Think about it. If you want to cut a piece of wood into 6 sectors, how many times do you need to cut that wood? Yes.
5 times. Because
20 divided by 5 is 4. 4
yes,
times 12,
that's
48.
because you only need to cut 5 times. You don't need to cut 6 times.
That would create 7 sections.
Yes. So, okay. So if you want to cut a wood into 30 sections, in this case, it would only need to cut it 12 times. Okay.
20 divided by 5 times 12.
Yes,
48.
yes. Thank you. If you would like to answer this question, you may want to answer it on the chat room. Okay. So now let's go back to the first part of this paper or of this question, because you cut it 5 times. How many minutes do you spend? You spend 20 minutes. So each cut requires how many times? Requires 20 divided by 5, and hence it will be 4 minutes. So we know that you cut each time you cut, you spend 4 minutes of it. Okay. Okay, let's go. So by this, you can immediately get our answer. So it will be, if you cut 12 times, what the times you take, it would be equal to 4 times 12, and it will be equal to 48 minutes. So our answer will be equals to 48. Okay, so the answer is equal to 48. Okay, so let's go to the next question. Question number 4. There are some chickens and rabbits, and the number of chickens is 4 times the number of rabbits. They have this length in total. How many chickens are there? So again, because the number of chickens is 4 times that of rabbit, now we can rewrite it. We can group all this. We can group 4 chickens with 1 rabbit. Now we can group them together. So it means that for every 5 animals, how many legs are there? They have how many legs? These 5 animals, 4 chickens and a rabbit, they will have 4 times 2, because there are 4 chickens, right? There are 4 chickens, right? They will be equals to 4 times 2 plus the 4 from the rabbit. So it will be 4 times 2
12.
plus 4 is equals to 12 legs, okay? So every 5 animals, it will have 4 legs, or have 12 legs. But how many legs are there in here? It has 108 legs. So 108, how many groups are there? So 108 legs means that if we divide it by our 12 legs per group, it means it will have exactly 9 groups. But what is the meaning of 9 groups? It means it will have 9 times 5 animals, or in other words, 45 animals. Okay. Now, of course, in here it does not ask for animals. Instead it asks for chickens. But every group will have 4 chickens, right? Or every group have 4 chickens, so it will have 36 chickens. Okay. So 36 is our answer. Okay. So we group them. If we group the animals in groups in different groups, because we know that for every rabbit they will have 4 chickens. So we group a rabbit and 4 chickens together. So we know that for all these animals, they will be formed they will be having the integral numbers of groups, and hence we can find out how many groups are there, and then we use the group to deduce how many chickens are there. Okay, so this is question number 4. Now let's go to question number 5. Now let's go to question number 5. Amy is reading a novel. Now Amy is reading a novel. A novel should read 1 page in the first day, 2 on the second, 3 on the third, until the total page you read is a multiple of 60. How many pages did we read until then? So, which in this case we want to find the cases in which the total pages is a multiple of 60. So, what is the total pages, right? The total is equals to this is 1 plus 2 plus 3 plus 4, and then add up to some numbers. Okay, we don't know this number, but we do know that
are multiple 60.
We do know that this, according to the Gauss theorem, it will be equal to n times n plus 1 divided by 2. Right, this is the Gauss summation. Okay, this is the Gauss summation. So now once you compute that, then so we know that this must be equals to a multiple of 60. So and in other words, we want a number n such that n times n plus 1 is a multiple of 120. So what's the smallest number such that it happens? The smallest number it happens is when n is equal to 15. Okay, so we know that n is equal to 15. Now you may ask, wait, how can I find this number? Well, this is not difficult, because in fact the smallest multiple of 120 is 120 itself, but 120 is exactly equal to 15 times 16, right? So you immediately see that n must be the smallest number will be equal to 15, and hence the total number, our total will be exactly our total is equals to our n times our n plus 1 divided by 2 equals to 60. So 60 is the total number of pages. Okay.
Yeah.
So this is question number 5. Now let's go to question number 6. Let's go to question number 6. Now, again, in here we have some pattern, 3, 8, 23, and 68. What is the next number? What is the next number? Now this number, this is difficult. This is really difficult. And let me state the laws,
Teacher,
the patterns. Yes.
can I show something?
Maybe later. Now let me
Okay.
finish it first. So because this is 3 to 8 is actually we want to multiply by 3 and then minus 1. 3 multiplied by 3 minus 1 is equal to 8, and then 8 multiplied by 3 minus 1 is equal to 23, and 23 multiplied by 3 minus 1 is equal to 68. So finally the rules will be 68 multiplied by 3 minus 1, it will be equals to our final answer, and hence our final answer will be equals to our 68 times 3. 68 times 3 is equals to what? 204 minus 1, and hence our answer is equals to 203. Okay. So our answer is equals to 203. So okay, so now this is the end of our the section of logical thinking. Is there any question for these 6 questions? Is there any question for the 6th question? And Joseph, is that something that you want to draw so that you want to show all others?
I noticed, book teacher, when I took the difference of the two numbers, it was like this.
Okay, yes.
Oh, wait. 55.
Yes, 35. So
And then
so
the
what's the next number?
one.
Why 55? They are different by 10, yes. And then 5 and 25 is different to 20, and finally, yeah, it should be 65. But even then, this is very contrived, right? It really doesn't show the true meaning of it, because why just 5? Why 5 to 15 to 35 to 65, right? Because why start from 5? Now, although that looking into the difference of number is very important for us to find the pattern, it is not the only way. And sometimes if we just give you this number, you may want to find a more direct way to state your difference. Okay. Well, okay. So someone says that it can show your solution to question 5 really quickly. Oh, for question 5, the question is no. You for question 5 again. You just write down the total pages, because what is the meaning of the total pages? Now the total will be equals to the first 1, 2, 3 up until to some number n. I don't know, because the n day. And we say that now we know that based on our Gaussian theory, the n 1 plus 2 plus 3 up until n, it will be equal to n times n plus 1 divided by 2. But then we know that this must be a multiple of 60. Multiple of 60. So we want to ask, wait, what number of n such that this will be a multiple of 60? If n times n plus 1 divided by 2 is multiple of 60, so which means that n times n plus 1 must be a multiple of 120, because we multiply both sides by 2, right? But 120 is equals to 15 times 16. So of course, in that case, we know that our n must be, our n can be equals to 15. So by this, we know that this answer, the total number, it will be equals to 16. 1 add until to 16. So it will be equal to 16, and hence this is our answer. Okay. Okay, is there another question? If no, then we will it will go to, I will go to the next part. I will go to the next part. Okay, so let's go to the next section, which is our arithmetic. We want to calculate all this number. Find the values of the sum.
I heard this trick.
Find the
Like-
value of the sum.
Can I?
Now, if you have any question, you may ask it later during the end of this section. Okay, find the value of
Can
the
I
sum.
annotate?
Excuse me, what do you mean? Now here, this is called a oh yeah, sure. Thank you. Yes, this is something that I would like to mention now. Now this method is called the telescoping. I don't know why this is called telescoping, but this is the name of the technique. Now telescoping, or sometimes we call it term splitting. We split this rational number into its several different terms. For example, for our first term, 1 times 2 over 1 over 1 times 2, we can split this term into two parts. It's 1 over 1 minus 1 over 2. For our second term, this can be split into 1 over 2 minus 1 over 3, and so on and so forth. So for our third term, it would be equals to 1 over 3 times minus 1 over 4. Now you can calculate it directly. You will see that each of this term, they are equal. Okay, so for our second last term, it would be equals to 1 over 1019 minus 1 over 1020. And for our final term, this will be equals to our 1 over 1020 minus 1 over 1021. Okay. Now, but in here, you can see that all these terms, they can cancel out, because minus 20 and minus 1 over 2 and plus 1 over 2 will cancel out. Minus 1 over 3 and 1 over 3 will cancel out. Okay, so
It's 1 over 1 minus 1
and
over
then
1021.
we will cancel them out. The only thing that does not cancel out is the
It's
first and our
101.
last term.
1 over 1 minus 1 over 1021.
Oh yes, this is exactly as in here. So it's 1 over 1 minus 1 over 21, and hence our answer is 1 over 20 divided by 1 over 21. And this is our answer. Okay, this method is called telescoping. We split the terms into this part, and then we find out that most of them can be canceled out. Okay, let's go to question number 8. Let's go to action number 8. Now find the value of this alternative sum. Okay, find the value of this alternative sum, and now every time we see this, because this is an alternative sum, it means that if we combine this term together, it will form a much smaller number. Now, if we combine this all together, so you can see what are the value of each term. If it is 15 minus 8, it is equal to 7. 29 minus 22 is again equal to 7. This is also equal to 7. This is also equal to 7. So now here comes our answer. So it will be equal to 5 plus 7 plus 7 plus 7 up until the plus 7 and finally plus another 7. So as long as we know how many 7s are here, then we can find out the answer. Okay? As long as we know how many 7s are here, and we can find out the answers. But how many 7s are here? Now, in order to find out the number of 7, we want to look back into this series. Now, if we just look at this number, you may want to ask, wait, why 7? Right? Why 7? How can we find out the number of terms? So in here, you can see that for all this term from 5 to our now, and except the first term, for all this term from our 8 and 15 and 22 and 29 up until our final term, except the first term, they are all a so-called arithmetic series. Now, what is the arithmetic series? Arithmetic series is a series which a neighboring number numbers have the same difference. So you can see very clearly in here, because for 8 and 15, their difference is 7. 22 and 29, their difference is 7, and so on. But also 15 and 22, their difference is also 7. So except the first term, all other terms are actually within a arithmetic series. So let us look into how many numbers are there for this arithmetic series. But for the numbers are here, we can make use of the equation for the number of series, number of terms for arithmetic series, it will be equals to our last term minus our first term, and then divide the whole thing by our common difference. Now, normally we refer to as the CD, but in here we'll just say that it's the difference, and then it will be, and then later on we would have to add 1 to indicate that we have 1 more than this, because we need to count the first term. So, or if we try to do this, this will be 211 minus 8 is equal to 203 divided by 7, and then plus 1. So 203 divided by 7, it will be equals to 29 plus 1, and it will equal to 30. So there are 30 terms here. Now, but it doesn't mean that it has 37 in here. Instead, it has only 15 sevens. Why? Because we combine each of these two terms into forming a 7. So there's only 15 sevens in here. So our answer in our question here is equal to 5 plus 7 times 15. Or in other words, 5 plus our 105, and hence it will be equal to 110. It is equal to our 110. Okay. So let's go to our next question, which is question number 9. Question number 9. Find the values of this expression. Now again, every time you want to compute the multiplication of a rational number, always remember to make all this number, to make all rational is a so-called the pseudo version of it. So we cannot have a number which have a carry integer. Make all rationals a pure ratio. Now, what does that mean? It means that we need to convert them. We, instead of having all this number that carries a integer, now we want to transform it into a pure ratio. So the first term, 3 and a 1/6, can be rewritten as 19/6. Okay, so it will be 19/6
times 13
times 13. Yes. So the second term,
plus
2
5
and
over
half,
2
it is 5/2
over 2
times 5. And finally, the final term, it will be 16/3 times 10. Yes, thank you. And if you would like to answer any more of this question, you may want to answer it in the chat room. Okay. Okay. So now, once we have done this, we can now try to multiply them together and then get the answer. So it will be 19. Now in here, there's not much things that we can do about that. Not much things that we can do about this. So the one of the better way of doing this is try to combine these two first. We want to combine these two first. Now, if we want to combine these two, now first of all, it will be 19 times 13. 19 times 13, which result in our answer equals to our 247. So it will be 247/6. Now our final term, it will be 16/3 or 320/3. Okay, so 320/3. And then later on, combine 2 and then we add up the final one, which is 25 divided by 2. Now we want to combine the green part first. If we combine the green part, what we get is the following. This is, instead of 3 is 160/3, and hence it will be 320/6. So if we add them together, so it will be equals to 367/6. (567/6). But 567/6, now because 567 is a multiple of 3, so we can reduce it further. And hence our answer will be equals to 189 divided by 2 plus our 25 divided by 2. And now after this, we add this together, so it will equal to 214/2, or in other words, it will be equals to 106. Okay. Now, so this is one way of doing this. Now, because of course, this is not the only way of doing this. Another way of doing this is to use the distributive law to reform this answer. Now, what do you mean by that? Because in here, 3 and 1/6, it can be written as 3 plus 1/6 and then multiplied by 13, right? And later is 2 plus 1/2 and multiplied by 5 plus our 5 plus 1/3 times 10. But then, if you think about it, you can now using distributive law to actually find out each and every one of them by placing all the multiplication inside the bracket, right? So the first one will be 3 times 13 plus 13/6 plus our 10, our 2 times 5 plus our 5/2 plus our 5 times 10 plus our 10/3. So we can collect all the integers together. So the first term is 39, the second term is 10, the third term is 50. So we collect them all together. So all we get is 99. So it will be 99 plus the remaining is 33/6 plus our 5/2 plus our 10/3. Now, Of course, we can further reduce it. We can further reduce it because our 33 over 6, it will be equal to 1 over 6 plus 2, right? 2 plus 1 over 6. And the second term is equals to 2 plus 1 over 2. And the final term is equals to 3 plus 1 over 3. So in other words, it's 99 plus 2 plus 2 plus 3. And hence it will be equal to 106 plus our 1 over 6 plus 1 over 2 plus 1 over 3. And hence it will be equal to 1 over 7 because 1 over 6 plus 1 over 2 plus 1 over 3 is exactly equal to 1. So this is another way of doing this. Now, both ways is correct. Both ways is correct. Okay, so now let us go to our question number 10. Let's go to question number 10. Find the values of this expression. Now you can see that these two numbers are very close to each other. And the other two are also very close to each other. So we may find that, so these two numbers are actually very similar. They are just different a very tiny bit. So let us write this tiny bit out. So instead of writing this, let me write it in the following form. So it will be 2356 multiplied by our, instead of saying that it is our 1370, if we write it 1369 plus 1. And the second part, instead of writing 1357, we write that is 2356 times 1. And then we multiply it by 1369. Now, after we write it like this, we can use our distributive law to rewrite. Now, again, we want to place our multiplication into each and every terms of the bracket. So it will be 2356 times 1369 plus our 2356 minus our 2356 times 1369 minus 1369. Okay, so this is just by pure expansion. Just by pure expansion. So, but in here, now we can, yeah, it's just because we can cancel this part, right? We can cancel this part. This is why we say that these two numbers are very similar, because the biggest number, they are actually this part and they can cancel each other. They are the same. So the final answer is 2356 minus our 1369. So at the end of the day, it would be equals to 987. And 987 is our answer. Okay. So let's go to question 11. We want to convert these numbers into decimal. Now notice that in here, in this case, it is actually it is actually strange because now this number cannot be written as a simple decimal. So what does it mean when, because if you try to divide it, you will find out that 38 cannot be divided by 9. 38 cannot be divided by 9. So what does that mean? It actually means that in here, the decimal actually means it is an infinite decimal. Or in other words, it is a so-called a recurring decimal. So usually we will write, now in here, let me introduce a concept which is called recurring decimal. Let's say something like this. 0 and 1 to 3, but unlike other, now this is a decimal, but unlike other decimal, there are two dots on the top of it. Now, what does that mean? It actually means that it is a decimal, but instead of a finite decimal, it is infinite. You just keep repeating the digit between these two decimals, between the two dots.
Wait, isn't that different from? Oh.
But we just keep on repeating the thing, the pattern in here. So this is called a recurring decimal, or sometimes we call it a infinite decimal. This is a recurring decimal. Now, whenever we write in a recurring decimal, it is always interesting to say that a recurring decimal can always be converted into a rational number. Now, the trick is to count how many terms are here. If you have 3 terms, all you need to do is just rewrite it such that the denominator is exactly equals to the number of 9 of which you have terms you have in as or digit. Okay, so if you understand this, then you can immediately see that this is the textbook definition, right? Which is exactly our textbook definition of a 0.38, 38, 38, 38, 38, and so on and so forth. And hence, this is exactly equals to 0.38. And you have a 2 dot at the very top of it. We start from 3 and then end with 8. So this is the decimal that we want.
How can we tie 2 dots on the exam, teacher?
No,
How
that's
can
not
we?
possible.
Well, yes,
I
of
mean,
course.
like,
Of course, this is possible. Okay, because you have answer that you can select it in the examination. Okay, you can answer. You can select the dot on the program. Okay, so now let's go to our final part of our arithmetic. So find the value of it. Now this one is now I would like you to compare this to the arithmetic series of in the previous exercises in the previous question. Recall that arithmetic series is that all neighboring number have the same difference. Okay, so let me rewrite it in here. A arithmetic series is that all neighboring number, all neighboring number has common difference. Now notice the keyword here is different. Notice the keyword here is different. But in this question, instead of arithmetic sequence, this question we will focus on something which called a geometric series. A geometric series is just like arithmetic series. Again, it is all neighboring number. But instead of common difference, they have the common ratio. So you can see that in here. Our 1/5 and 1/25, the denominator is just 5 times our numerator. So in other words, you just multiply the whole number by 1/5. So again, for the next two number, 1/25, if we multiply the whole number by 1/5, and then you get 1/125, and then so on and so forth. Now, this is what we call a geometric series. Now, in order for you to calculate the geometric series, let's call the number sum. So now let us find out what's happening if we sum is divided by 5. The sum is divided by our common ratio, right? Then this will be equal to 1/25 plus 1/125 plus 1/625 plus 1/3125 plus 1/15625 plus, finally, now notice that our last term still need to multiply by 5. And if we multiply them, what we have is the following. What we have is the following, is that our 15625 multiplied by 5, it will get is 1/78125. Okay. But notice that, well, isn't this two parts so very similar? No, it's not just similar, they are the same. They're exactly the same, right? So we can rewrite the sum as the following. We can rewrite the sum as the following. It will be equals to our number s minus our 1/5, but plus our final term is 78125. So by rearranging it, what we get is our s. Now we can subtract both sides by our s here. So what we get is the following. We get is our 4s/5. It will be equals to our 1/5 minus 1/5 minus 1/78125. Now this would be hard to calculate, but you can try, you can find it out. It will be 15624 divided by 78125. But then all you need to do is just multiply both sides by 5 and then divide it by 4. So what we get is the following: 15624 divided by 4. So it will be equals to our s is equals to our 3906. 3906 divided by 15625. Okay. So in fact, like the arithmetic series, there are equations for this for this kind of series, the sum of the series. But in here, I do not use that method. I do not use the equation because I know that some of you may not know the equations, may not be very familiarized with the geometric series, but because we know that because all neighboring numbers have the common ratio, we can immediately multiply the common ratio such that we can instead shifting the terms. And this is one of the ways for you to compute the sum of it. Now, this technique itself is very useful. Okay. So this is the end of part 2 of this paper. Is there a question? This is the end of part 2. If no, let's go to part 3, number theory. The remainder divided a positive integer by 22 is 6. What's the remainder divided by 4k minus 7 by 8? 4k minus 7 by 8. Now, what does this mean? Dividing a positive integer by 22 is 6. Okay, so let us rewrite it. K divided by 22 is equal to something. Now, well, we don't know what that thing is. Let's call it S, right? And then the remainder is 6. Okay. But this, we can rewrite this. Rewrite it as the following. We know that our K can now be rewritten as 22S plus our 6, right? This is the remainder theorem. This is the remainder theorem. We can rewrite a division into a equation into a. We can rewrite our division into a multiplication, and we get a equal values of it. So now let us use this part. Let us use our remainder theorem and then substitute this K into this here. So now let us see what is the value of our 4k, minus 7. So according to our theory, this our k is equal to 22s plus 6. So it will be divided by 7, and hence it will be equals to minus 7. So it will be equals to 88s plus 24 minus 7, and hence it will be equal to 88s plus our 17. But now here comes the question. What is this number when divided by 8? We want to divide by 8. Notice that this number, now our 88s itself is a multiple of 8, right? So if we divide it by 8, this part contribute nothing. So all we need to do is the 17. So, but 17 divided by 8 is exactly equal to 1. It has a remainder of 1. So the whole number has a remainder of 1. Okay, so this is the question 13. Okay, again, based on the remainder theorem, we can rewrite our information of k divided by 22 has a remainder of 6 into k is some multiple of 22s plus 6. And then we substitute this k into our equation, and hence we can rewrite our 4k minus 7 into 88s plus 17. And after we divide this by 8, we know that the 88s it will be equals to 11s. Now this is our quotient, which has nothing to do with our remainder. But the remainder is contributed only by the 17. But 17 divided by 8 has a remainder of 1. So the whole number will have a remainder of 1. Okay. So let's go to our question 14. Let's go to our question 14. Our question 14, if a 9-digit number 2021382678 is divisible by 7. Now, divisible 7 is difficult. This is difficult to do. Now, how can we know whether some number is divisible by 7 or not? It is so-called a free, so this is by making use of the so-called free point. So the 3-digit determinant. So what's the meaning of 3-digit determinant? It says the following. If this 9-digit number is divisible by 7, so if we try to add all the number in blue and then subtract it by all the number in green, we will get it. This number is also divisible by 7. This is what there was, in certain sense, is very similar to the case of the sum of the digits for divisibility by 9. But in this case, instead of dividing 1 by 1, digit by digit, we divide it into 3 digits altogether. So, but in here, we know that this number will be equals, well, what does this look like? What does this look like? So it would be equals to our 480 minus 130. So it will be equals to, this should be equals to 350. 350 minus a is divisible by 7. But this is strange, right? Because 313 is divisible by 7 all by itself. So, which means that the only possible way for it to also be divisible by 7 is that our a is also divisible by 7. then since a is divisible by 7, a is divisible, a is greater than 5, so which means that our a must be equal to 7. So this is our answer. Now, if we do not have this part, now this part is here because it wants to stop having our a equal to 0, because a equal to 0 is also one of the answer if we are allowed that a is less, can be less than 5. But after we constrain ourselves that our a must be greater than 5, then a equals 7 is the only answer. It is the only answer. Now let's go to question 15. Let's go to question 15. Find the last digit of this multiplication. Now this is very difficult, but we know that the last digit is only affected by the last digit of each of these terms of the multiples. Right? It can only affected by all this last digit. So in certain sense, although it looks like it has 12 different numbers, all it do is just repeatedly multiplying 4, 7, and 9 4 times. So their last digit is the same as multiplying 4 times 7 times 9 and 4 times. But what is 4 times 7 times 9? What's 4 times 7 times 9? 9 times 7 is 63 multiplied by 4. So it gets a last digit as 2. So it was equivalent to 2 to the power of 2 multiplied itself 4 times. So it has the last digit of
6.
6. Yes, 6. So our answer is equals to 6. Our answer is equal to 6. Okay, let's go to our question 16. Find the number of all possible factors of 1, 5.
4 times 2 equals 8, teacher.
Excuse me?
The teacher 4 times 2, is it 8?
No. Why? Because what does that mean? This means 2 times 2 times 2 times 2. If we multiply them 4 times, this is the meaning of our index, right? 2 to the power 4 is 2 times 2 times 2 times 2. We multiply it 4 times instead of 2 times 4. So this number is actually equal to 16. So the final digit is actually equal to 6. Okay. Okay, so now let's go to our question 16. Find the number of all positive factors of 1, 5, 3, 9. Now, whenever we see a question which is about the number of factors or the sum of factors, the first step we want to do is just prime factorize the number. What do you mean by prime factorize? Prime factorization. In other words, we want to write our target number in as a multiplication of a series of prime. So for our 1539, for our 1539, we can divide. We clearly see that it can be divisible by 3. So we can keep on divisible by 3. So it will be equals to 3 times 3 times 3 times 3 times 19. Okay. Or in other words, using the notation that we have is 3 to the power 4 times 19 to the power of 1. Okay. Now, Now, once you write it in this form, the number of factors is given out by number of factors can be given out using this formula. The formula is that you get all the index of the prime. You get all the index of the prime. You try to
It's 5 times 2.
Yes, you try to add it by 1, and then you multiply them together. Okay, so it will be equal to 4 plus 1 multiplied by our 1 plus 1. So in here, it would be something like this. Now, the reason of it is you just count the number of factors in each term. So it will be equal to 5 times 2, and the intensity will be equal to 10. Okay. Now, of course, another way of doing this is you just list out all the factors of it. So it is not very difficult in listing out. All the 10 factors are this 1, 3, 9, 27, 50, 81, and then the next part is 19, and then it will be equals to our 57, and then 171, and then it will be equals to our 513, and finally 1389. So you can, again, by counting all this number, you will also get our answer in here, which is 10. Okay. So let's go to our question. Let's go to our question. Let's go to our question 17. Let's go to our question 17. A 3-digit number have a remainder of 2 and divided by 3, have a remainder of 2 and divided by 4, and have a remainder of 5 and divided by 7, which is unfortunate. So what's the smallest number satisfy this equation? Now, whenever we see this number, we want to, now this is a 3-digit number, not just 12.
So 12.
Now, first of all, we want to combine the first. Now, can you find a number such that when it's divided by 3 is 2 and divided by 2 is 0? Well, now, do not consider this first. Do not consider this first.
It's 14.
If the easiest number that satisfies these two conditions now is 2. Now, we have yet to consider our last condition, right? If we want a number that divided by 3 is 2 and divided by 4 is also 2, then it will be equals to
14.
2. But then, not just 2, but what's the all other number? Because after this, it will be 2 plus a multiple of 12, right? Because after
14.
if we subtract it by the multiple of 12, it will have a remainder of 2. So it can be either 2, 14, and then you will be going to 26, and then 48, and so on and so forth. Now, but in here, in order for it to divide by, it will have a remainder of 5 when divided by 7. So it will be 5, 12, 9, 19, and then 26, and then 30. Yeah, and then 33, and so on. So what is the common digit of it? Common values of all this condition? Is it 26, right? 14 when divided by 7, it is not a it doesn't have a remainder of 5. Okay. So now here comes the base case. So once we get the base case, we know that our answer must be 26 plus something. That thing is a common multiple of 4, 3, 4, and 7, because we know that the common multiple of 3, 4, and 7 is 3 times 4 times 7, and that is equal to 84. So it will be so it will be 26 times some multiple of 84. So again, by this, we can just list them all out. We can just list all the numbers all out. So it starts from our 26. And then the next one, it will be 110, and then 194, and so on and so forth. So which one is the least, is the smallest three-digit number? The small three-digit number is
110.
obviously
Well,
110. Okay, so 110 is our answer. 110 is our answer. Okay. So is there any question for question 17? Is there a question for question 17? Because I see people. Twins, is there any question for question 17? Is there any question for that? If no, then we will proceed to our question 18. Okay, so now let's go to question 18. The sum of two positive number A and B is 42. Find the maximum value of the product of it. And now, in here, it requires a very, very important truth about sum and product. If the sum is the same, the product is maximum when, if and only if, when the two number,
Are close to each other.
are
closest to each other.
Yes.
to each other. Okay, so this is the most important modern mathematical fact that we would like to use in this cases. So in here, as long as because we know that the sum is equals to 42. So what are the two numbers that are closest to each other, and then their sum is 42? Which means that they can be, the closest to each other is that they are the same, right? If they are the same and they sum up into 42, then each of them must be 21, right? So the product, the maximum product is equal to 21 times 21 is equal to 441. Okay, so 441 is our maximum, right? So then by this, we have finished the section of number theory. We have finished the section of number theory. Now let us proceed to the next part of the paper. The next part of the paper, our geometry. Now, how many triangles are there? How many rectangles are there? How many rectangles are there that contains the two stars?
1, 2, 3.
Now let us just draw a rectangle which contains the two stars, and notice what's the criteria. Now notice this black rectangle. Now I will draw it using a much bolder. Yeah, notice this black rectangle. It contains the two stars, right? It contains the two stars. But now let us, instead of considering this rectangle, let us consider its four sizes. You have a red size, the left side. You have a blue, which is his right side. You have its green, which is its top size. And we have its orange, which is its bottom size. So what's the criteria of this four size? Let us look into our bottom. I've said that the bottom can only be in this position. Why? Because they must be low enough to contain both stars, right? Suppose the bottom is in here. Then no matter what rectangle, what other size it will be, it will gonna contain the bottom stars, right? So in order for them to contain all two stars, the bottom must be within the lower the lowest possible position of it. So there's only one way to select the bottom. How about the top? Again, if it is going to contain all 2 stars, the top must be above the 2 stars, which is this 3 positions. So the top can only select it in this 3 position. How about the right? For the right, because it must be the right of all the stars, which means that it can only be selected in these 2 positions, because it needs to be on the right of all stars. Otherwise, the right hand side of the rectangle does not cover, is not right enough to cover all the stars, so it will not contain the 2 stars. Okay. Finally, let us look at the left side, And for our left side, so in here, it must be on the left of all the stars, which is 1, 2, 3, 4, 5. So there are 5 different positions for this. A rectangle consists of 4 different sizes. So there are, so let me write it down now. We have 3 ways for our top, 1 way for the bottom, 5 ways for our left, and 2 ways for our
3
right.
times 1 times 5 times 2 is
Yes,
30.
exactly, right? Exactly. So we know that they will have exact in total, which is by the rules of multiplication, the total will then be equal to 5 times 1 times 3 times 1 times 5 times 2, it will equal to 30. Okay. So this is question 19. Now let's go to question 20. Let's go to question 20. If the radius of the circle is 4, then the size of the square. Yes. So if you are not available, you may leave now, and because this lesson is recorded, so you can rewatch the payover later. Okay. So now let us go to question 20. If the radius of a circle is 4 and the size of a square is equal to circumference of a circle, find the perimeter of the square. But what is the perimeter? A perimeter for a square is exactly 4 times the size, right? This is exactly equal to 4 times the size. So, but what is the size? The size length of the square is equal to its circumference, right? So it is equals to 4 times the circumference. Please do not draw on the screen unless I told you so. 4 times the circumference, right? But what is the circumference? A circumference is because the radius is equal
Circumference
to
is the
4. So
the
the circumference will be equals to 4. Now again, this is the 4, but the circumference is equals to the pi times our diameter. But diameter is equal to 8 because its radius is equals to 4. So we know that the answer will be equal to 32 pi. So 32 pi is our answer. Now let's go to our question 21. Let's go to our question 21. How many rectangles are here? How many rectangles are there in the diagram? Now there are 2 different methods of counting this. There are two different methods of counting this. One is using inclusion-exclusion principle, which unfortunately is a little bit difficult. So instead, we will use a much more basic method, which we simply call the count by sizes.
Can I show my
Excuse me.
Can I show?
And maybe let me show them together, show them all. Okay, so we counted by an area. So we can now, or what we count by classification. It will be a better name. We classify all this rectangle into all different shape. So the basic one is is just like this. So the basic one is just like this. How many of them are in here? So we 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 14. So this will be 14 in here. So this is the most basic of all rectangle. Now, after this, we have a rectangle which is elongated, combining two rectangles side by side, like this. So how many of them in here? So we have 1 in here, and then we have 2 in here, 3, 4, 5, and then go on 6, 7, 8, 9, 10, 11, 6, 7, 8, 9, and 10. So there are 10 of them for this shape. Okay. Now, but this is not the only way of doing this. We can be even longer. We can be even longer. Now, but for even longer, then the things start to change. And so instead, now the top part is no longer available. So all we have is just this one, 1, 2, 3, and then 4, 5, 6. Okay, so there are 6 of them. Four, 5, 6. So there's only 6 of them. Now we can.
Something's wrong with the solution. When you're, when you mean these 2 squares put together? Wait, how do I?
Excuse me. What
This
what,
one, is
yes?
it only vertically or also horizontally?
Only
Horizontal.
horizontally. Only horizontally. Yes, only horizontally.
Okay.
So, because if we consider vertically together, then it will be very, very confusing. So we want to make it simple. We use a simplest method. Later on, we will use a, now again, this is a four rectangle pairing up together. So it will be 1, 2, 3, 4, and just like the one drawn in here. And finally, we have 5 of them pairing up to get each other. There will be only 2 of them. Okay, there are only 2 of them. So this is what we call
Teacher, there's more than 4.
Excuse me, what do you mean?
Square blocks, he's only referring to straight lines, not the square 4. He's only.
Okay, now after this, we need, now these are all of the width equals to 1. Now we would like to consider the width is equals to 2. So let us consider the rectangle like this. We combine the rectangle up and down. So the rectangle like this. So this will be 1, this will be 2, 3, 4, 5, 6, and then 7, 8, 9. Okay. So there will be 9 of them. So after this, we will consider extending this. Now the later on, this part is just the same as the thing that we have. So we, instead of this would be a, so this will be a cross, and how many of them? So it will be 1, 2, 3, 4, 5, 6. Okay, so it will be 6 of them. Now you just keep on counting them all. You just keep on counting them also. Now this method is tedious, but it is the simplest method that you can find. This is the simplest method that you can find. So again, in here you will find only 3 of them. And then later on it will be only 2 and then only 1. Okay. So you will have 2 in here and 1 in here. Now, after we count all the rectangles of width 2, then we count all the rectangles of width 3. Now, in this case, there are not much rectangles in here. There are only 2 different sizes. One is of this, and the other is of this. So we have 4 on our left-hand side. This one have 4, and they have 2 of them on the right-hand side. 2 in here. And finally, we can find out the
A.
we can find out the length of width 4, which again we have 2 different ways of writing this. We can 2 different ways of writing this. One of them is just yes. So it will be 2 of them in here and 1 of them in here. Now, again, this is not the best method of doing this, but this is the simplest, easiest to understand. We classify them all. And finally, what we want to do is just add this number all together. By adding this number all together, what we get is the final answer, right? So for all the green, for all the rectangle which is of length 1, so it's 14 times 10 plus 10 plus 6 plus 4 plus 2, so it will be equal to 36. For all the red rectangle, it will be 9 plus 6, 15, and then it will be equal to 21. For all the green, for all the blue, it will be equal to 6, and for all the orange, it will be equal to 3. So our answer at the end, total is equals to 36 plus 21 plus 6
66.
plus 3. So it will be equals to 57. 57
No,
plus
66.
66, okay?
Yay.
Okay, so this is the answer for question 21. Now, question one is a little bit tedious. Now, later on in our secondary school, we will learn about the inclusion-exclusion principle. We will learn about the representation, and then we will calculate it using the combinatorics coefficient, which we will see later. Okay, so let's go to our question 22. Now, I'm sorry, it may take a little bit more time for us to finish it. So this lesson may be finished in roughly 55 to 40 past 1. Okay, so for our question 22, it's known that the length of the shortest side of a right angle triangle. Now, again, this is something that is very useful, which we call a Pythagoras theorem. Pythagoras theorem. The Pythagoras theorem says something like this. If you are given that now, excuse me, please do not draw in first. Please do not draw in first, okay? Let me draw because we need to state the Pythagoras theorem first. Now, if we have a right angle triangle, of size A, B, and C, and it's same C. So the Pythagoras theorem says that, okay, so these three sizes, the length of these three sizes are correlated. We know that the C multiplied by C is exactly equals to our A multiplied by A plus our
U
B
squared.
multiplied by B, yes, or in other words, B squared. Now, but because we already know that A and B, what's the value of A and B? It is equals to 9 and it is equals to 40. So we can directly substitute into it, and hence we get our value, which is the square of our hypotenuse. It is equals to 9 times 9 plus our 40 times 40. So it will be equals to 1681. But what is the value of 1681? 1681 is exactly equal to 41 times 41. So it means, so we know that our size, the square of our size is equal to the square of 41, hence our size is equal to 41. Now again, by applying Pythagoras theorem, you can very easily calculate the result of it. Okay, so for question 23, a square is found by 722 rectangles that are 1 cm and 2 cm. Find the decrease in parameter in centimeters. Now, if we have this so many rectangles, what's the parameter? The parameter in this cases for the 722 rectangle, it will be 722 multiplied to the parameter of each sizes. So it will be 1 plus 2 plus 2. Hence our answer is equals to 4332. So because each of this square, each of this rectangle will have a parameter of this. So we need to multiply by 722. But what is the area of this? Now, why we want to calculate area is because we want to later calculate the area of our rectangle. It will be equals to 722 times our 1 times 2, it is equals to 1444. But 1444, what is the it is exactly equal to 38 times 38. So we know that the size of this square is 38 times 38. So we know that the size of the square is equal to 38. And hence its parameter is equals to equal to 38 times 4 is equal to 152. So what's the difference? What's the difference between this number and this number? The difference is huge, right? The difference is equals to 4882 minus 152. It is equals to, the difference is equals to 4180. So this is our answer of 23. Okay. Now let's finish this question quickly as the administrator is causing is actually announcing. Further figures below, the figures formed by three cubes. The side length of the cube from the biggest to smallest are 13, 7, and 3 representative. What is the volume? but the volume is just the sum of all this, right? The volume is just the sum of the the sum of the volume of the three squares. So the for volume of the largest cube is exactly equals to 13 times 13 times 13. So if we multiply them together, it would be equals to 2197. The volume of the second largest, volume of the middle one, the medium cube, is exactly equal to 7 times 7 times 7. So our answer will be equals to 343. And finally, our volume of our last cube of the smallest one
square.
of those cube is exactly equal to 3 times 3 times 3, which is equals to our 27. So all we need to do is just sum them all up. So the total will be just equals, the total will be just equals to 197 plus our 343 plus our 27. So by summing that all up, so our answer is equals to our 2883. Okay. Now, unfortunately, from a time constraint, I am afraid that we cannot finish the whole paper. But I hope you can learn something about it. Now, I will continue until the end of this lesson.
Teacher,
Okay.
will you give answer to us?
I'm afraid I cannot. So, but let's pretend I have book be distributed in 3 distinct boxes, such that every one contains at least one book. So again, this question is you just try to divide it, and the answer for this is the combinatorial coefficients 9C3, 9C2, which is equal to 9 times 8 divided by 2, and the answer is 36. So this one is for our question 25. For question 26, choose 3-digit without repetition to form a 3-digit numbers. How many numbers can be divided by 9? So in order for it to be divided by 9, so this, again, the sum of the digit, sum of the number must be also be divided by 9. The sum of the digit must also be divided by 9, divisible by 9. So let us find out how many numbers can we find such that is divisible by 9. So it's not that much. It would be is our 1. Now it would be our 1 plus 3, 3 plus 8. No, this is not divisible by 9. And 1 plus 3 plus 4, no. 1 plus 3 is 6, no. 3 plus 4 plus 6, no. The only one that can be is 1 plus 6 plus 8. I think it's only 1 plus 4 plus 6 plus 8 and no others, right? Because you cannot sum them up into 9. So how many because there's only one way of doing this. So the number of way is to rearranging these 3 numbers. So the number will be equal to 3p3 is equal to 3 times 2 times 1, and hence it will be equal to 6. So this is the answer of 26. Okay, so for our 27, the number of drawn in this, I don't have a number of drawn so that the 2 numbers who different. So in here, we know that if 2 numbers is different by 24, for example, it will be 31 and 55, 32 and 56, and so on and so forth, up until to our 54 and our 78. Okay, but we can keep on writing it because it is 31, 55, and then it will be another difference is 79. And then now notice that all numbers within the same line, they are all different by 24. So 79 plus 24, it will be 108, 103, and then it will be 127, 151, and finally 175. Okay, so now you can exactly doing the same thing over and over. So it will be 128 and then 152 and then 176 and so on and so forth until the last one, which is 102, 126, 150, and 179. Now in here you can see that for all the terms within the first one, because now again against every time you see the at least, you are thinking about the principle of the least. You are thinking about the principle, the worst case scenario, okay? You're thinking about the worst case. And hence it would be, and hence for our first line, you can only choose 1, 2, 3, 4 numbers for our first line, because you cannot choose any neighboring number, right? You can choose any neighboring number. So there's only 4 numbers in the first line, the 4 numbers on our second, and so on, until it goes to our 35. So it will be 35, 59, 83, 107, 131, 155, and then is 170. Oh, no, 156. 60, 84, 8, 132, 159. So all the numbers before that we can select 4 of them, and all numbers that is more than this, we can only select 3 of them. So in a total will be equals to 4 times our 6 plus our 3 times our, because it's 31 to 54, it will be equals to 25. Now this is 24 of them. 24 of them minus 6 of them will be 18, and hence it will be equals to 4 plus our 18 times 3, it will be 78. But 78 is the worst case scenario, so we know that we need to add 1 here. We need to add 1 here. So our answer will be equals to 79. 79 is our answer for our question 27. Okay. Thank you very much for your attendance, and this is the end of the lesson. I'm sorry because of the time restriction, we cannot finish this paper. But I will count on you to finish the last 3 questions. Okay. Thank you very much for attendance, and I hope you have a wonderful day, and goodbye.